Yeah, hi everyone. Thanks for joining us, and thank you so much, James and Elizabeth, for having me here. Real quick about myself, my name is Philip Koller. I'm from a small town in Switzerland, living in Berlin now for 14 years, where I came for studying visual communication. I founded a studio early on during studies with two of my classmates, Julia Schelm and Lukas Küng, which is called Burrow, a design studio based in Berlin. Still running today. It's actually 100% of my job. I will be more talking about my side project today, which is called Burrow Lab. But it's really connected to my work as a graphic designer, working closely with clients from the cultural sector, from artists to cultural institution, working in print, web, exhibition design, kind of the whole range. And we all early on decided a bit to find our own focus within this landscape. And for example, for me, I got interested in type actually after studies, as well as coding. I didn't really code throughout the studies. I actually tried to avoid it and got really into it afterwards when I learned what cool things you can do on websites as well. So, but today I would actually be talking about Burro Lab, which is a project that came out of our everyday practice. And initially the idea was to kind of design our own tool where we can quickly create fonts for showcasing purposes or prototype fonts where you kind of just choose a typographic style and then it kind of populates throughout the whole typeface. Meaning you kind of choose how heavy a font looks like and the general style, and then it gets just automated. I learned later on that this is known as parametric type. So what I'm actually doing is a parametric type system. And I just have to point out early on in this presentation that all of this, what I'm showing is work in progress. So it's really rough around the edges, just a bit like this animation could also get a bit more love, but I think it encapsulates really well what kind of is the purpose of this application. So I would like to go to a few points. So first, I give you a little bit of an overview for those of you who might not be familiar with the project, what it's doing or what it's capable of. Then a little bit of historical context. Then I will show you a little screencast from the application itself. I dig a little bit into the algorithm, but not too much on the lower technical level, but just to give you a bit of an idea what's behind the system. And in the end, also talk a little bit about further steps I would like to take and goals and challenges ahead. So yeah, let's start with a real quick overview. So first, this is just a little screencast of kind of me twisting parameters around within the tool itself. So the tool, just to give an outline, is a website basically. It's essentially a website that you can change parameters and you get a font as an output. The font is rendered as a SVG in the browser, so it's all vector based. And here is just a little bit of a preview what you can do. So it's kind of seamless transition between different states. It's a bit wonky here because I'm moving the parameters and I don't have the calmest hand myself, but and you can see that there is bugs and glitches happening here all the way, because the idea is a bit that you use parameters to change the style of the font, but you have so many parameters that you can change in parallel that here and there something goes wrong, because maybe it's not intended that it works, or it's a glitch or a bug. And I'm actually also excited about the whole side effects that come out of the application. So in a nutshell, a bit how it works is on a technical level, you have two inputs from the user. So you as a designer using this application, you would provide the typographic style, here a bit illustrated on the left side. So just as you would do with a variable font, for example, you change the weight of the font, you can change the roundedness of the curves, X height and stuff like this. And on the right side, you have like all the character set that you would like to render the font in. And in the middle, you have the output. So just this sounds maybe like a lot to start with, but the idea is that the parameters are always there. They are just here for you to change to get to your result. And also the whole glyph set you can use as a preset and just change it a little bit. So you don't have to really start from scratch. You actually start with a font as a preview or a preset that you can build up to. So this is roughly the idea of it. And to give a little bit of a context of parametric type, it has actually quite a long history. The idea of it was born in the 1970s already with Metafont. You can still use that today in a software called LaTeX, which is often used for scientific papers and such. And you can see there was quite of an influx of projects between 2006 and 2013, which is probably to technological advances. And all this project kind of have their own kind of concept how to deal with parametric oriented type design. One of which is computer type from Christoph Knot, which is also the mentor of my project. Prototypo was a big project that was going on for 10 years and had really promising results. Unfortunately, it was closed in 2020. And yeah, on the right side, you see 3 projects that I'm aware of that are going on right now that I quickly would like to mention. So you have Leather Ink. They're producing really nice calligraphy tools for Illustrator and Glyphs app. And they're also working on a parametric type concept, as well as font post by family type, which has a really promising look. But I think they have a bit of a different concept and don't work with skeleton, which I will go a bit into later on. Just to give a bit of context, why I go through this whole struggle is, so first quickly to look at digital type itself. So the way it works right now is you have a type design software that enables you to create a font. So you kind of draw the font and this will be turned into a data set. And there is 3 big companies, I think mainly right now, who are defining how this data set look like. So this incorporates all the open type feature, like all the technical features that you have in a font file and then can use in any software that supports fonts. So OTFs or TTF, the font files we're familiar with, you can produce in a design software, and then you can use it in a type design software, and then use it in different softwares, which start from a text editor, just showing the font, going up to design software, where you really squeeze the font, scale it, rotate it, change colors, etc. And you can also go into motion, animate the font, or even 3D. The problem is a bit you have, or the challenges, this font file or the specification of this font file give you a lot of possibilities, like for example, variable fonts that we have. And but it also comes with all the restrictions from it. So if you want to turn it into 3D, you probably lose the font properties and have to turn it into a vector, then into an object. And this was part of the struggle for me as a designer, was for many projects needed like 4 different softwares and just using a small aspect of every of the softwares. So the idea here a bit with the parametric type approach is that it's a bit more interconnected. So you can design the font, meaning you change the parameters, you get from maybe a really bold typeface to a hairstyle type, and then you start animate it. So you open a different window in your browser, jump over to the motion type software, change a bit of the keyframes, and then maybe you realize you're not really happy how the font looks in detail. So you can jump back over into the design part of the software and change maybe ink traps or something like this, like a small details. And the motion part of the software would just adapt and take these little changes inside without having to build the whole animation again. And the same goes for 3D. You can apply 3-dimensional effects to it. And when you go back to change the actual font into a lightweight typeface, for example, it just get automatically updated. And that is kind of the idea, or I think what inspired me to keep going with this project is really that it's extremely fluid way of working with type. And the type can really change, or the font can change from one look to a completely different one without having to deal with the outline itself. So yeah, to get a better understanding, it's just a small screenshot from the status quo of the application. So it's again, it's a website, so you can open it in the browser. We'll also share the link for the demo in the end. You also have a lot of sliders, just like in Kiel's project as well. And you can change all the typographic parameters. So on the left side, you have the toolbar, which right now opens the type design aspect of the software. And you can see it's like actually a lot of slider with partially cryptical labels. So it's really hard to actually define these parameters. And so part of the project is also to give them a bit of a visual interface. So those sliders will also be changed into a bit more intuitive interface. And you can see a bit on the right directly the result. This is also, you don't have to wait for it to appear. You just type in a word, or you can choose a random word on the bottom and change the parameter and then see what happens. And oh yeah, maybe this part also. So it's also built in a really modular way. So you can actually exchange part of the software itself. So in this case, you have like a particle filter using the initially generated outline to place circles and dots around the outline, and also using a noise, Berlin noise or randomness to scale up and down these particles. And you can also use some kind of physics where you move the dots up or to the bottom and do all kinds of things. Actually, this part of the software could also be programmed by a creative coder. I'm working on an interface so other people could write their own script and generate a whole range of new effects on top of it. So it's kind of the idea to provide a tool for other people to also extend on it and work in their own ideas on top. Yeah, and then just real quick, I would like to jump a little bit into the algorithm, just to give you a bit of an idea what are the steps to actually get to this result, and also maybe to explain a bit why I'm doing this. It's like when you want to have an animation between two characters that are as distinct as those two, for example, you see directly that they don't share the same amount of nodes on the outline. So this is a bit the challenge with variable fonts, which people usually handle by overlapping the serifs on one dot on the corner. So you have like three dots that are on the same spot. And for parametric type, the idea is a bit to find the common denominator of those two fonts or those two letters, and actually describe the letter more as kind of a blueprint or the DNA of the letter. So you really it all comes down actually to the line in the end. And this also has a bunch of advantages, which I go into later. But the idea is to use the line to describe a letter. So basically the hairline of the font, or the skeleton line, how it's also called. And here is a little animation how that would work with an interface. So this is an illustration of drawing the letter N. And this is kind of what the user is doing, drawing the letter. And the next step is for the algorithm to determine the skeleton. So here come in the first parameters, because you define how high the letter is, how wide it is. And you also define the stroke weight or choose a tool that you would like to draw the letter in. So you can kind of imagine a bit like calligraphy. You have like a really thick pen or thin pen. And all these parameters are already calculated in for the generation of the skeleton. So here you see how the skeleton is calculated. So it's basically the ellipse used to offset the skeleton from the borders that you're given by parameters. So this would be the first step. The second step is then to offset the skeleton, because eventually we want to have the outline of the skeleton line, but we use the skeleton and the ellipses to calculate the outline, or in this case, the offsetted lines from the skeleton. And the last step for the algorithm is, and this is all part that the algorithm is doing, but just a bit to explain all the process the program goes through. And the last step is to connect all these lines to get an outline. And that would be the last step. So now you have the letter N. And this same principle is going through all the characters that you use for for display, or if you export the font, you can go through the whole character set. And this is also done, this whole process is done every time you change a parameter. It goes through all those steps. So just to look at it real quick again as a kind of a schema. So the idea is really for the user to draw as simple shape as possible. So it can be a bit like a connected dot type of thing. You really just define all the corners and then connect the lines. It's the process you do for a letter, and then you mix in with the parameters, or you can do that later, changing the parameters to get a new look of the typeface. And then the first step for the algorithm is to generate a skeleton, given the current parameters. And from the skeleton, the outline is calculated in the second step. So yeah, right now we went through a lot of hustle just to get a kind of classic sans serif font. So this is not the end of it. So the next step, or what we can still do, we can still further manipulate this outline. And the classic use case for it would be the serifs. So we're running a subroutine, meaning going to all the dots within our letters and determine where to add a serif or not. And like when we go back to this first drawing previously, when you draw the N, you can also choose where you would like to add a serif. And what the algorithm would be doing, like in this case, also rotating the ellipse and squeeze it a bit, so you get more of a contrast in the font. And in the second step, it adds the serif on every corner that it's necessary. And yeah, of course, because it's parametric type, you don't draw the serif everywhere yourself, but you have kind of an interface where you can choose, or I mean, also draw and change the serif how you would like to have it. This is at the moment just hypothetical, but this is how it should work. And you can choose the style of the serif, and given the situation, like for example, when you have a diagonal line, of course, the serif is handled a bit differently than when you have a vertical line. And just to give you another idea, there's different use case also for subroutines, like for example, the rounding of fonts. So you go to the whole outline and round all the corners that are necessary. Or also popular for ink traps, where you would cut in, like in a narrow connection of two lines, a little bit more into the corner to make the letter appear a little bit lighter, or just as a stylistic element as well. So here the crosses represent the original notes, and then with the cut in, just illustrated here, of course you wouldn't do it like this, but different types of ink traps that you could control by parameters. And that was, I in the beginning thought that was kind of all the steps, but then later on I realized actually I could do another step between the skeleton and the outline, because the parameter just looks what it has and then passes it on to the next step. And if I actually use a subroutine to manipulate the skeleton, I could also take in the letter N as a skeleton, then run something like a zigzag line over this N, and then the outline would just do what it automatically does and run through the zigzag line and generate something like this. So here also again the ellipse or the circle to see how the outline is generated. Alternatively, you can also take the skeleton line and split it up in equal distances, and then place, for example, a circle there for the lack of something more interesting. And of course, then you can change the distance between the circles, or you can use Perlin noise to scale a certain circle. Could do the same effect on the outline. You can play a bit with the original outline and the circles by inverting the path direction, so you get like this negative effect, this cutout effect, or you just kind of completely lose the recognition of the letter if you play around with it. And yeah, this was just an example with circles, because it's always easy to illustrate, but you could also, like a creative coder could also design their own script. For example, you could also just let grass grow all over the outline or something similar. Yeah, and I hope this helps a bit to just show you some things that you could do with this application. And the thing I just showed you with the letter N is maybe not so exciting when you see it with one letter. But also just more illustrative example. But for me, what's really exciting is, especially with this approach of coming from the skeleton line, is that you're not limited to a specific script, because pretty much all the fonts are somehow created with a tool, and for that you need a line. And you can just use this line also to do all kinds of effects on it. So if I put circles, for example, on an outline of a Latin script, the same principle would work like here for a katakana script, for example. And also, every change you do is can be populated throughout the whole script that is available. So I think it's going to be really excited once the whole tool gets a bit beyond Latin script, which is, of course, the one that I'm most familiar with and I'm focusing on right now. But so this is one big plan ahead, to really support more different scripts and work with people that are actually really familiar with those scripts, to make sure that they can implement it in a way that they're really useful. And yeah. Then another thing is really always to improve the algorithm. And to be honest, it's quite a lot of math to get to wrap your head around Bezier curves and such, and work with those. So it will be also reading a lot of papers and making decisions. Sometimes the solution is not just to make a curve more round, or to correct the roundness of a curve automatically, because maybe the intention from the person changing the parameter is a different one than I would expect as a programmer. So it's a bit the challenge of making the whole thing either complicated but flexible, or intuitive but limited. And it's always kind of a balance of the two. So you go for more complexity, which makes it much more confusing, or you go for a bit more intuitive way, but then actually kind of already decide how it works, and not leaving a lot of room to experiment. Another thing focusing the next half year will be a good documentation. So for people of you that are maybe really interested in more details of the project that I'm able to share right now, I think in half a year you should have a really good, or really an improved documentation about the project, with more details, how things work behind the scene. And last but not least, of course, the whole project would also be a bit useless if we cannot use this font. So a big chunk of it is actually the export. And for that, I'm working together with Florian Zia, who is responsible for the whole backend side, to turn the parametric font into a usable OTF. So at the moment, we have been testing just regular static font files, but you can also export variable fonts. You just have to define a few axes before you do that from within the type tool. And we also did some tests with color fonts. So this is all stuff that is coming. I think at the moment, in the demo, you can just export a SVG file with all the letters. So it's all vector. It will be transferable to an outline font. And just one little thing is that we haven't really taken so much care with spacing and kerning, as it's a bit like on the second priority, because there is some good mechanisms to calculate that. And right now we're really focusing on the form. So you can change spacing and kerning, but they're not parametric at this point. Yeah, so that was about it. Just like a little bit of thank you to the collaboration and support I received so far. Like the main collaboration I just mentioned with Florian Zia, is really doing great work making this parametric tool hopefully be useful to more people later on. And my studio partner, Julia Schell, who always also lets me work sometimes during studio hours when I have an idea on this project. And Alessia Meyer, who's also working with us as a freelancer sometimes, and also helped me a lot with the interface side of the project. And of course, everyone who's testing it and constantly providing feedback is also really appreciated. And just a quick mention also of my mentors. The project is also part of my master's studies right now in Burgiebichensteil Halle, near Berlin. And I get typographic support from my professor, Andrea Tines. and also my second mentor, Christoph Knot, who is really familiar with parametric type concept, as he built one himself, and gives me really honest critique on the regular. Yeah, if you interested in the project and haven't followed it yet, you can check it out on Instagram with handle Burrow Lab. So I treat it kind of like an open sketchbook, so really showing everything I can or what I just record on screen. You can also check out the demo, which is free available on burrolab.com/demo. And if you're interested what our design studio is doing, you can also check out in Burrow. Yeah, and that was about it for today.